What deal?
I can see you. You can see me. All right. How are you?
Doing good. How are you?
Boy, it's been one of those busy, crazy days. It's just pretty much the way it always is, I guess.
Yeah, I hear that. So,
what you
go
got?
ahead.
No, go ahead.
I don't. I'm sure she relayed to you a little bit about the ovens, and that I'm having a little trouble with them, sizing them for, I don't know, like apartment complexes and
Yep.
stuff like that. And then the three phase calculations, the 1.73, when I need to input that into a calculation.
So 1.73. What? Yeah, I could use a code book, please. So the you talking about 1.73 three-phase calculations doing range calculations?
Well, I mean, I don't think we're going to come across three-phase ranges in
well, see, that's what the reason why I'm asking is because there is a master's question that seemed like everybody's got lately, and it's a three-phase service that's feeding single-phase ranges. I think there's probably either 20 or 40 ranges that are 12 kW. Does that sound somewhat familiar?
Yes.
Okay. So it's a three-phase service that's feeding a bunch of residential dwellings and with all single-phase ranges, right?
Right.
The trick on that is actually a really complicated calculation, but you're in luck. They stole it out of the back of the code book, literally lifted it. Word for word.
Oh, really?
Yeah.
And so like one of the examples back here?
Yep, it's one of the Annex D examples. Let me find it real quick. I mean, it's literally the exact scenario that they ask on the test, and their answers in there as well. So it's better to just jot that down, the page down, and try to, because it's a very complicated calculation that doesn't make any sense.
Yeah, and I'm afraid that I'm going to spend a lot of time on these calculations trying to figure them out, because there's going to be so much involved in it.
Some of them are pretty complicated. Like, you really do have to spend some time and be involved with them, but not all of them.
Okay.
Sorry, I didn't mean to cut you off. So page 798.
Okay.
Right-hand side of the page, kind of toward the top right-hand column where it says minimum size feeders for 20 dwelling units, 10 of them with ranges. And then there's a block right below that says minimum size main feeder, less house load for 40 dwelling, 20 of them with ranges. Do you see that?
No, I saw that. Well, I see the minimum size feeder required for service equipment to meter bank for 20 dwelling units with 10 ranges.
Keep going all the way down to the middle of the page where it says minimum size feeder, less house load.
Oh, okay. I see it.
So I've seen both of those as test questions, but the main one I'm seeing lately is the 20 ranges, right? Which is going to be the one that's a little further down on the page. And so they're basically looking for what's the equivalent three-phase load using some single-phase appliances. And quite frankly, it's kind of a weird math, because it's basically taking single-phase loads and trying to artificially backwards calculate them into a three-phase service. But you'll see that it says, kind of in the middle of the inset block, it says the equivalent three-phase load is 43,500 VA.
Right.
That's it.
And that's that a calculated load?
That is the demand load.
That's the demand load.
Yep.
Maximum number between any two phases. Table. So, I mean, how do we begin to even calculate this?
So it's an artificial rule. If you really want to know how to do it, I mean, I don't mind showing you, but it's really it's a waste of time, because it's such
okay. Okay. Well, yeah, I don't want to go into too much depth of it, but I just don't, if it asks me how, say there's an apartment complex, it's got 250 ovens, 250 dryers, what's the grounded conductor service entrance size on the wire, how am I gonna?
Okay, well, that's a different calculation. This one I'm showing you right here is just specifically this one rare offshoot that they ask. And so if you have this question, it will literally be that answer. Or Or
Okay.
if it's 20 ranges, or I'm sorry, 10 ranges, it would be the one that's above there, which is the 34,500. So just highlight both of those. And if you get that one question, just
Okay, just hop back here and check it out.
yeah.
Okay.
And again, I'm not trying to shut you down because I know how to do the math of it, but it's really bizarre. And I mean,
Right. And it confuses me. So
right.
I
And
don't know.
there's no need in this case since it's.
So you don't think they're going to get into too much depth of it like that to where they're going to expect you to break all this out and calculate it all out?
I mean, I could show you really quick. So if you really want, so if you go to page 74 in your code book, page 74, we're going to go to look at the table. I'm sorry, we need to be on 73, which is the article that controls the table. But
okay.
So we're talking about 220.55, which is the range table. Let's go to. Did I say 54? I meant
220.55.
Yeah, I meant 74. If I didn't say that, I apologize.
Okay. Yeah. No, I see it now.
Did I say 54 or 74?
You said page 73, but I think you meant 74.
Well, actually, the calculation that we're going to do is on page 73, but let's talk about the table on 74 first, right?
Okay. Right.
So this table on page 74 is the most complicated table in the entire code book. Like it really truly is the most bizarre, complex. It's a hybrid. It's got different values, and we use it for two different calculations, and that's what you got to be careful of because you can have two questions that look identical. They've got the same ranges, the same sizes, the same number, and everything. But one could be calculating a service calculation or the demand on the feeders, and one would be a branch circuit calculation or the demand on the branch circuit. And two different applications of the same table. So let's look at it for its primary use, which was what it was invented for, and that's the service calculation. This is a demand table to get us to that demand load instead of the connected load or the nameplate load, like what we get for equipment rating, right?
Right.
How do we do that? Well, all right, let's say that we had, an A or a B or a C range. So if you look at the top of the table, column A says less than 3.5 kW. But what I want you to do is I want you to change that wording to where it says basically 0 to 34.99.
0 to what?
0 to 34.99. I just want you to write that. Just write that, kind of on the top of column A. And the reason why I'm doing that is because you can
34.99.
34.99. Yeah.
34.99. Okay.
Because it's pretty much. It's easy to look at and go, okay, 0 to 34.99. You know exactly what fits there and what doesn't, right?
Right.
The way it's written now is less than 30 or 3.5 kW. You really kind of have to stop and think, okay, well, less than 3.5 kW is not 3,500, right? 3,500 is actually more than that, which is what column B starts with. So column B, I want you to write above it 3,500 through 8750, and that way you've got kind of an easy way to tag it and understand which column you should be in.
Okay. 3,500 through 8750.
Yeah. All right. So then the next thing is let's talk about what those columns are, right? So column A and column B, they look just like each other. They appear pretty much the same kind of deal. They're what these are is their demand factors. So these are the vehicles that get us from the connected load to the demand load so that we can get that calculated value that we actually use to size feeders or branch circuits, breakers, that kind of thing.
Okay.
All right. So when you get an appliance, go to Home Depot and you buy a GE range, right?
Right.
And and have you ever noticed how the ranges, like the nameplate for ranges, is hard to find?
Yeah.
They're not on the back they're not on the back.
Isn't it on the back or something?
It's not on the back. It's not. You take the back off, and it's not behind it. It's in the bottom underneath the drawer warmer every freaking time. Which I don't know why they thought that was a good idea to put it. Anyway, so
I think microwaves are sometimes like that. You got to open the door and read inside of it or something.
Yeah, exactly. So bottom line is that number that you see on that sticker in the drawer or on the door, that's an imaginary number because somebody put that thing in a laboratory and then they hooked up test equipment to it and then turned everything that it could possibly have on at 100% on.
Okay.
So they basically let it burn in, right? And that
Right.
burn-in value, or that maximum peak value, is what that nameplate is.
That's the maximum load.
Maximum on time. Like you wouldn't expect to see that actually probably ever hit, right? Because the
Right.
reality is we don't use all 4 burners at 100% ever.
Right.
Plus the oven itself at full capacity. So it's the nameplate, right? It's just it's the maximum value that could possibly have. Well, we don't size anything that we have to do with based off of that number. It's not a realistic number. So we have to figure out, how do we get from that nameplate to that demand load, which is what we're actually trying to shoot for. And that's what this table does for us. These are the factors that get us the difference of those two numbers.
Okay.
So when I see a nameplate on a test question, the first thing I'm trying to ask myself is, well, what about multiplying? What factor do I need to apply to that thing? Because a lot of guys will just take that nameplate and then try to apply the math straight to that nameplate, but that's not ever really the way it works. So let's just say we had a range that was sized as, I don't know, 5,000 watts, right?
Right.
So the manufacturer said, all right, we put this thing in the lab and turned everything on, and we got 5,000 watts out of that thing. So how do we figure out how much does that actually contribute to the feeders on the outside of the building, or, in the house? So let's see here. I'm going to see if I can log in and use.
So that's going to fall under column B.
Exactly. You can use the nameplate to select a column, right?
Right.
And then, since I just have one appliance, right? That's what that top row is. So over on the far left-hand side, the number of appliances is 1. So I'm going to choose the value that I see under column B on row 1, which is 80. And that's a multiplier. That's a factor. So it's 0.80 on your calculator.
Right.
So you would.
So we're going to times that by 0.80.
Yep. You would take the nameplate times 5,000 and multiply it times 0.80.
We'll do this 4,000. What?
Huh?
Yeah. So it comes out to 4,000.
Yep.
Okay. Now ovens. We're going to say it's 240 volts. When does that come into play? Oh.
Sorry.
No, that's fine. I feel like I'm in a fishbowl.
Yeah.
I'm sorry, what was the question?
So they're going to be 240 volt. Do we need to take voltage into any calculations here, or because they gave us that 5 kW rating, we don't need voltage to figure that out?
That's a really good question. Typically, what we're doing with these numbers, we're trying to calculate the feeders, right? Now, feeders are based on ampacity, but traditionally, what we do is we express everything in volt amps, and then we put it all on one great big list, add all of the loads up in volt amps, because it's hard to calculate. Like when you're adding amps, it's pretty easy, but you got to remember the 240 volt version and the 120 volts. Most of the time our calculations in the code book come out in watts. So we just add them up in total VA or total watts, and then divide the whole thing at the end by 240 volts.
Okay. At the end.
At the end. So like that 4,000 that we just calculated, right? It's not really useful to us because we're not using that for a branch circuit calculation. We're just trying to figure out how much that appliance contributes to the feeders outside. That's it. So it wouldn't really do us any good. I mean, you could divide it by 240 volts, and they could certainly ask you that, but it's not really relevant.
Would that 5,000 on the nameplate, would that be the first calculated load that they give us? And then you, by times in, the number of appliances, 1 by the 80%, would that now become the demand?
Correct. So we call the first one the connected load, the second one the demand load.
Okay, so it's connected load. Okay.
Yep, the nameplate's just another type of connected load.
Okay, all right. That answers the question.
And then the demand load, of course, being the factor derated. And remember, demand factors can sometimes be an increase. So like with continuous duty is a demand factor. It goes the opposite direction.
Right. And we say derate, but really you're just changing the rating.
I'm just rating it, right?
Right. Okay. Yeah. Okay.
Really the correct word to use is factoring, because I can factor a number that's 100% plus some other value.
Right.
But I get lazy and call it derates, which is not.
Really. I do the same thing. I call it derating it, and it might go up. Okay. So, okay. What is the, down below here in the notes, it'll say something about adding a kilowatt for every 10 or 20. I don't know what it.
Okay, down at the
I was
bottom.
reading it somewhere in here. I was reading it somewhere in here. Over 1.3 kW. I guess it's number 3 through 8.75 kW.
Okay, we're gonna get to that in a minute. You're getting
Okay. Okay.
because first, before I get to the notes, I want to make sure we kind of understand what this table is and the differences between the columns, because that's really the kind of the
Right.
first part of it. So
Okay.
you'll notice that column A and column B kind of look like each other because they're basically double factor numbers all the way down. Now they're the same on row 1, but you get into 2 appliances and 3 appliances, so on and so forth. Column B goes down faster to a lower overall percentage. So column A, basically, you keep more of the nameplate than you do on column B, which is neither here nor there. Now, column C, though, is a whole different animal. Let me see if I can log in on my iPad and be able to, so that way I can draw some pictures, because feel kind of hamstrung not being able to have a chalkboard. So let me.
Yeah.
I'm gonna pause saying back in the day, but it was when my parents were growing up. They'd be like, "Now we're cooking with gas." I'm like, I don't really get the reference to that. Maybe I guess there was some ad campaign back in the 40s or 50s or some gas company trying to say they were better than electricity.
Yeah.
Gas, to me, I'm not scared of electricity, but I am scared of gas. So I mean, there's definitely.
Especially, gasoline too.
Yeah. One second, I'm trying to find a stylus. Give me 1 second. Anyway, while I'm getting this ready, I can go. While I'm digging through this, I can try to keep talking. So the column C, right? The column C. The first thing you got to realize about column C at the top there, it doesn't say. Like B says, it starts with one number and ends with another number, right?
Right.
But this one doesn't. It just says anything less than 87. No, anything less than 12 kW.
Maximum demand. It says not over 12 kW.
Right. So.
I mean, there's got to be an oven over 12. Okay, this is just one column. Okay, yeah. So it's not.
Here's the thing. You just hit the nail on the head, or the nail on the head. Almost all the ranges I've ever seen professionally are bigger than 12 kW. Right. I mean, even the cheap GE profile stuff that you can buy at Home Depot, those things are like 11,500 or something like that. They're pretty good size. So I never understood why this table kind of stopped just when it was getting good, right?
Yeah,
however,
right.
The nice thing about column C, let's say that we have a range that's sized as 9,000 watts, right? So earlier what we did was we had a 5,000 watt range. Now when we had the 5,000 watt nameplate, we said, okay, this is a column B range, just from the nameplate, right? Right. So that's what set us over there with that 80%. So we took the 5,000, we multiplied it times 0.80, the demand factor, and that gave us 4,000 watts of calculated demand load. Right. That's a lot of work. We got to get our own factoring. We got to do our own math. We got to break out a calculator. I mean, all of this has got to be processed to do a column A or column B for that matter. Column C, somebody already did the math for me. That 8 that you're looking at is simply the math of one range that does not exceed 12 kW max, right?
The 8?
Anything basically from 8750 51. We'll just loosely say that for now. But 8751 all the way to 12 kW, anything that falls in that range is simply going to equal 8,000 watts, and I'm done. Oh, really? So those are already the demand loads. Exactly. That's exactly right. You got it. Not over 12 kW, but I mean, okay, does that go for the rest of them down the line here? I mean, we got to calculate the rest of them, huh? I'm proud of you, because that's the right question to ask. Why does it say less than 12 kW? Let me ask you, is a 5,000 watt less than 12 kW? It is. So how do you know to do it in B or C? I mean, you get to choose any time. I mean, that doesn't make sense either. No, I guess you just go to the closest one, or if it's in between there, use column B. I mean, if it's over column B, use
column C?
You always want to use column A or column B if you can, right? So if
Right.
the range is sized to be a column, well, you know what, let me back up. Before I do that, let me go back and forget the column C for a second. Let's go back to column A and B for a minute. What do you do if you have two ranges that one of them is 5,000? Sorry, let me put my pen back. One of them is 5,000 watts, and I got another one that's 4,500 watts. So I got in the same kitchen, in the same house, same service, same feeders. I've got two ranges that calculate out each one individually. One's 5,000, one's 4,500. How do I deal with that?
We're going to go to column B, number of appliances 2, and that just add the watts up and times it by 0.65.
Exactly. That's exactly right. I always kind of qualify, you know, I just ask myself, what column does this range fall under? In this case, they're both under column B. So combined value, we have 9,500 combined total connected load or nameplate rating. That would be multiplied times 0.65.
Okay. So now if we had a range that was a 10,000 or a 10 kW, I don't need to do anything because there's my rating under column C. My demand load is 8. You could automatically bring it down from a 10 to an 8.
Correct.
Okay.
Likewise, what if you had two ranges that were, let me erase this so I've got some room here. Is this helpful? Is this whiteboard helpful?
No, yes, I'm looking at it. I'm visualizing it too. So
let's say we had the 9,000 we had a second ago, right? And you look at it and go, okay, that's column C, you recognize that. And then you look over here and you have another 10,000 watt range. So now you got two of them. You go to row 2, right? Since you get two separate appliances in column C now, you go to row 2 in column C, and the number that you see there is the total calculated demand load for both those ranges done. There's nothing.
Oh, really?
Yep. Nothing else to do.
Ah.
Somebody already did the math. So that combined total is just simply equal to 11,000 watts.
I don't know why they make column C like that. Why not just make it like A and B so we could just calculate it out? They just do this to just make it confusing.
Well,
you really got to understand this table.
It gets worse, and you're going to figure out. You're going to see here pretty quickly at the end why they do it this way. But it does seem kind of weird because. But anyway, that 9,500 example we had came out to be 6175. All right.
Okay.
And I want you to remember that number. If you could write that down somewhere, because we're going to come back and use these exact two ranges here in a minute in a different example.
6175. Am I write down?
Yeah, 6175.
Okay.
And we'll come back and we're going to probably basically do the same one, but just in a different manner here in a little bit. See if we have the same calculus. But anyway, so all right. So what do you do if you have I don't know. What if we had a range that was sized as 2,500 watts, and then you had a range sized as 4,500 watts, and then they go on to tell you had one that was 3,000 watts, and then you had another one that was 5,000 watts. So now you got, it's a big kitchen, right? Somebody's dream, home kitchen.
Right.
You have 4 ranges, but they're not all in the same column. So if you look down at that note 3 that you were talking about a second ago, that's what note 3 does for us. It lets us take things like this that are in different columns, separate them into piles so that we put whatever belongs in each A and each B, and then do the math of each one independently and then add them together when it's all said and done.
Okay.
I said that real fast, but basically what we're going to do is we're going to take the 2,500 watts, right? Because that's column A, right?
Right.
And we also have a 3,000 watt, which is column A. The pair of these, if we do them separately on row 2 in column A, is going to give us a demand factor of 75%. Yeah, 75%.
2, yeah, it would be 75.
So we're going to do the math of that one, and then we're going to do the math of the other pair, which are going to be the ones that are in column B, the 4,500 watts. I said amps. I'm sorry, watts. Sorry.
4,500 and 5K. And then that'll be the times, well, now we got 2 of those, so it'll be times 0.65.
Yeah. And we just did that a minute ago. It came out to be 6175, right?
Yep, 6175.
And then the pair up there at the top would be 5,500 times 75%, which is going to be 4,125. I did it in my head. Let's see if that's right.
The 55 times 0.75. 0.75 equals 41.25.
Oh man, come on! I nailed that.
You get it?
I said 41.25. I'm gonna roll back the tape here in a minute. We'll see. All right, 41.25. Now, what I've just done, right? I want to be clear. What I just did was I calculated the demand load for this pair, and it came out to be this number here, right?
Yep.
I calculated the demand load for this pair, which came out to the 61.75.
Right.
Both of those are now demand loads. Those combine now for the total answer, because it's basically all four of these together on the feeders equal those two values. So we take
10,300.
It'd be 10,325. Yeah. Or 300. No, 300. Yeah, you're right. 300. That's exactly right. Good. Hey, see, there you go. Good job yourself.
Okay. And then what do we do with that? That's
it. That's it. We're done. That's the demand on the feeders for those four ranges.
So how come we didn't come down to column or note 3 and use anything out of here?
We did.
We did?
Note 3 is what gives us the permission to do this business up here, which is this separating them into piles.
Okay.
Because if we didn't have note 3, we would have to do all four of these together. We really couldn't do it because all four, they're in different columns, right?
Yeah, they're all in different columns.
So if we didn't have note 3 to give us the permission to do that, then we would basically not be able to
okay. I gotcha.
Or we would have had to assume what? That they're all the worst case scenario, right?
Right.
Now, here's what's weird about note 3. It starts out saying, in lieu of the method provided in column C. And then, not only that, that's your first clue. The second clue is, there is no prescribed written method to deal with column C ranges that are mixed in with other ranges, like there is with column A and B, which we specifically give us instruction manual for. They don't do that with column C. In other words, column C does not mix well with any other range. They don't play well together.
Okay.
If I had a 9,000 watt range.
So those would have to be calculated out by themselves alone.
No, everything becomes a column C range.
Okay, right.
So even though I may have smaller ranges like this pair here, the 3,500 and the 4,500 I've got up there, this 9,000 watt range now makes all three of these column C ranges. That's why column C doesn't say 8751 through 12 kW. It says less than 12 kW.
Right.
Because when you mix them, they're all column C.
So we can mix them.
No, you cannot separate them. So for example, what I'm saying is, all right, so we had a question that gave us 4,500 watts, right?
Right.
When it says 3,500 watts, we know that both of those are column B, and we know exactly how to calculate that.
Right.
But then you could have a question that also throws in a 2,500 watt, right? Which is now a column A. Well, we have a rule that says, all right, I can take this column A and put it over here. I can put this pair over here in column B, do the math separately, and then add both together when it's all said and done, right?
Right, right.
But what happens if you have a column C range in addition to those other ones? What happens if we had a column C range that was a 9,000 watt range added in the mix?
I feel like I would have to separate that 9,000 out.
That's the point. There is no way to separate it. They're now all going to be in column C. So instead of doing them separately and doing all the hard work we did, we simply go to row 4 and it's 17,000 watts.
So because they put that column C in there, I can now put those together?
Everything becomes column C. That's
okay.
A column C, that's a column C, that's a column C. I have 4 column C ranges now.
Oh, wow. Okay. I see.
Column A and B can be mixed and matched, commingled, whatever. You can separate them, do the math. Column C cannot be separated. If you get a column C in a question, everything in it becomes column C.
Okay. Gotcha. All right. Well, that clears that up a little bit.
Now let's get into the more complicated part of column C.
Okay.
From the onset, column C is fairly easy looking because it's real simple. If I have a 9,500 watt range, I don't even have to do any math. I just simply go, okay, well that 9,500 watts equals 8,000 watts. It's just a substitute. Somebody already did the math. But what if I have to do something that is, let's say that I had a 10,000 watt range and I had a 12,000 watt range. Now I've got 2 separate appliances but they both happen to fall in column C, so no harm, no foul. I just go over and go, okay, on row 2, the demand factor for that pair is going to equal 11,000 combined total watts. And that's my answer, right? Those go away, and that's all I have left.
Right. Okay.
Now,
I don't know why they don't put KW after
I don't
the
either.
numbers going down.
But what I would suggest you do is put a comma 000 watts.
Right. Yeah, that's what I just put KW next to each one down.
Yeah, I prefer to see it in watts in this case. I usually like KW better, but for me, I think sometimes they get. I think that 8 sometimes misleading. But either way, at least you got.
When I'm just looking at this table, I'm just like thinking it's a percentage because everything else is. But you know, it's about you cleared that up for me now.
Now here we go. What if you have arranged? So you understand if we have arranged, and I'm going to tell you, I want you to write this exactly like this on your scratch piece of paper. I'm going to write you a little bracket, okay? I'm going to put a line right here. And then I'm going to put a number that is 12 kW. And I'm going to put, I'm sorry, I didn't mean KW.
There you go.
KW. Easy. Where's my pen? Sorry, give me a second. I'm
No worries.
all right, KW.
Yeah.
Now at the top though, that other row is also KW. It's a blank KW. So you're gonna fill in the blank, right?
Okay.
Now, we're gonna come down here, we're gonna do equals, and anything in green or blue is gonna always stay just like it is. So it's gonna be your framework. Equals, and then you're gonna write 8,000 watts, okay? And then draw you a great big line under the whole thing.
Equals 8,000 watt. Okay.
Now, I'm going to go back over here. I'm going to get my fill in the blank. I'm going to have to do some math here. So these two top ones, this one minus the 12 kW is going to give me this number down here. I'll show you here in a minute what this means. And then the X is always going to be there. And you're going to put a 1 point blank. Just like that. All right, now I'm going to explain all this, but I want you to write that framework on a piece of paper. If you will use this framework and just fill the blanks, you can do any range you ever need to do, and you'll never get sideways. Okay? And I'm going to show you how. All right. So, I wish I had a way to like move that over a little bit so that I could save that, but I don't think I can. Too bad. Okay, so what do you do if you have a range that's equal to, I don't know, 14 kW?
If it's equal to 14 kW, the range?
They give you a test question. Okay, you got a range that's the nameplate's 14 kW. I go over to column C and I go, crap, column C stops at 12 kW. Now what do?
Right.
So note 1 is probably the most commonly used, and it's probably the most importantly, or the most important one of all of them. And note 1 basically says, all right, look, you go off that chart one step, you're going to get hit right smack dab in the face with 5%. And oh my goodness, I can't believe I just did that. That's not what I meant to do. I meant to also tell you, so there's one piece I was missing. Let me just go back here and just do it real quick, KW. Okay. Because this is important. I really think this is a good way to kind of keep this straight. Equals 8,000 watts. I'm just going to do it all in blue. The stuff that's in blue, you won't ever have to erase. It's always going to be the same value. And then times 1 point blank. So you know what? I need to do, this needs to be times 0.05 equals 1 point blank. All right, now we're good. Now we go back to my purple example. So I got a 14 kW range, right? So what I'm going to do is I'm going to plug that 14 kW that they gave me in the test question in my little bracket. So I want to do the math of the top row there and this bottom row. So when I'm doing 14 minus 12 kW, because remember, column C is good for the first 12 kW is good for 8,000 watts, right? So what we're doing here is we're basically taking this substitute every single time. So we're just basically saying, okay, this first 12 kW is going to always equal that 8,000. So that exchange always happens. That's why it's just written there in stone.
For one
range, that's right. Now, after I do the math, what I'm doing here is I'm basically saying, okay, how many steps did I go past that chart? how far beyond 12 kW did I go? Because every one of those steps cost me a penalty. So 14 kW, the nameplate, minus the 12 kW leaves me with basically 2 additional steps.
Oh, I see where you're going.
Huh?
I see where you're going with this. Yep. Okay.
Now this 0.5 will always be 0.5. This will always be times. This will always be a placeholder, so all of that stays the same. This bracket here with the 12 kW will stay the same, the 8,000, so all that stays the same. So 2 times 0.05 is equal to 10%, right?
Mm-hmm.
So all I did was just do the math down here, going from here to this direction,
Right.
I started this way and went down, and then I'm going this way. What I've got left over then is this last final calculation, which is this block right here, which is the adjustment block. I'm going to take that original base demand factor in column C, and I'm going to hit it with 100% of the original number. That's what this 1 does, right? And then the increased factor of 10% on all in one step. So I'm going to multiply 8,000 times 1.10. And that's going to give you 8,800 and 800 watts.
800.
Now, don't worry about trying to write this down, because we're going to do several examples of this. So I'm going to just clean this up back to what our original little spot was, which was basically the framework, right? This framework will help you because it's a nice, clean way to just kind of keep track of it, right?
Right.
That you're seeing there in blue is basically what you want to keep track of, because this is our formula, so to speak, that will give us the answer that we're needing to calculate. Why is that not? Okay. So this is my answer right here in kW. All right. So give me a range size. Just pick a number.
15.
All right, 15 kW. So I come over here, I plug my 15 kW in. I go, all right, I got 15 kW range. 15 kW. Now, this block of 12 for the first 8,000, that happens every time. So I'm just looking at the difference of the 12 and the 15, which is 3. 3 times 5% is 15%. And then I do the 8,000 watts times the 1.15, which gives me 9,200, or, since I've got kW written there, 9.2 kW. Oops. Sorry.
So the 15 kW minus 12 gives you the 3. Yep, times 0.05 equals 1.15.
Yep. Every step we go off the chart. That's what this 3 represents. We went off that chart 3 single kW steps. Each one of those steps cost me a 5% penalty of the original base 8,000.
All right.
So we ended up taking 15 extra % of 8,000. You could have done it like this, where you just took the 15% by itself, and you would have just gone, okay, times 0.15, and that would have given you 9. We give you 9. Let's see, it'd be 900 watts. Yeah, 10,000 watts. No, sorry, 1,200 watts. Sorry, it's late in the day.
Okay.
All right, so 8,000 plus the 12 gives us the combined total of 9,200, right?
Right.
So I'm just basically doing that. I'm just basically doing the extra step there of putting the 1 in front of that, just so that it does the 100% included in that step all with one step. So instead of having to do that as a separate step and then add them together, when I do 8,000 times 1.15, it takes 100% of the original number plus the 15% all in one step.
Mm-hmm.
Anyway, you know, that's I mean, it's not really that big a deal. All right. So let's go back and let's try one more time, just so this kind of burns in. So if we had a range that was sized as, I'm going to put this back together because I've erased too much of it. All right. What if we had a 21 kW range? Could you still calculate it under note 1?
Yes, up to 27.
Okay. So you do that.
Okay.
Calculator 1 is 21,000 watts is the nameplate, 21 kW.
Okay. Let's see
Tell me
here.
the demand load on the feeders, on the outside of the service feeders for this residential dwelling. What would the calculated demand load be for a 21 kW single range?
9 times 0.05 equals 1.45. 8,123 times 1.45. 11,600.
What? Nah, yeah. What?
Did I get it?
Come on, there's no way you could have gotten that right. Let's see here. So we put 21 in here. 21 minus 12 is what, 9?
Yes.
9 times 5 is 45, right?
9 times, yeah.
So 8,000 times 1.45 would give me I don't have a calculator. I gotta use my phone.
8,000 times 1.45. 11,600.
There you go. And that didn't even hurt, did it?
No, that one pretty easy.
So if you will write that blue framework somewhere in your code book, right?
Right there.
All right. Now, and this works for any time you get a range that goes off column C, this will work. Now, the only time it won't work is if you get really big numbers that get down in those bottom 2 rows, which is like the above 26 or above 41, but I'll show you an example of that here in a minute. But I just wanted you to kind of understand the basics. Now, so what happened, then here's the way I've always looked at it. If I have one range, right, just one range by itself, for me, I've kind of always looked at it like this. I've got the first 12 kW is going to equal 8,000 watts, right?
Right.
And then a 13 kW, which is basically just plus 1 kW, right? Well, what's 5%? No one tells me I got to take 5%, 8,000. What is 5% 8,000?
8,000. 400.
400 what? Watts?
Yes.
Yeah. So what I've always thought about it like this. If I go off the chart one step and I'm on row 1, then really what I'm doing is I'm just simply adding 400 watts to the base of 8,000. And it's going to be the same additional increment for every kW. So if you think about it like this, a 14 kW range would be plus 400 again. A 1500 kW would be plus 400 again. So I just really looked at it like this. If I had a 17 kW range, right? How many steps off the chart is a 17 kW range?
Off of the 12 kW?
Mm-hmm.
5.
Thank you. Okay, so I went over 5 steps, right?
Yep.
Each one of those 5 steps cost me 400 watts. I can do that in my head. I don't even have to use a calculator.
2,000.
Now, the 2,000 just simply gets added on to the base 8,000 that's in column C, and I'm done. 10,000 total
10,000.
watts. Yep.
Okay, so anything over the 12 is
It's
going to be
plus 400 watts.
about another 400 watts.
So in my code book, what I have written on that next to that line is I have a real succinct, simple line that says, all right, plus 1 kW equals 400 watts. That's my mental memory note of what that calculation is. And then as long as I'm in row 1, I just do it like that. It's a lot easier. Now, it only works on row 1 because 5% of 11,000 is a different number, right?
Right.
So, but you're going to find here in a minute that you'll be using row 1 a lot more often than you think. But just suffice to say, it's a pretty handy tool. All right, so that's that part. Now, what if we had multiple ranges that go further down the chart and they go off the chart? So let's say that we had, let's say that we had 9 ranges that equal 15,000 watts. It's like, holy crap, Batman, that's not even on the chart anymore. We're not even in Kansas anymore.
Right.
So I'm on row 9, right? So I'm going to go back and I'm going to put that framework I had there a minute ago. I'm going to put it back up here because remember, minus 12 kW. Remember how we did that before? And we did equals 8,000 watts?
Yep.
Except this time I'm going to use this 9 to find my number that's different than 8,000. I'm going to get the same call. We're just going to be on row 9 instead of row 1. So 9 ranges on column C is 24,000,
Four.
right? So
Yeah.
instead of writing down 8,000, I'm gonna write 24,000.
24,000.
But beyond that,
We went down. We're dealing with multiple ovens now.
yeah. And now let me make this really clear. Once I use that 9 to write that 24,000 down, I don't care anymore how many ranges. I couldn't care less. It's got nothing to do with anything anymore.
Okay, because you got
That
the value of
24,000
9.
that 24,000 already has all 9 of those factored into it.
Right.
So if that's the case, I do everything else exactly the same way I just did with everything else. I'm just going to do how many times they go off the chart. Well, I went off it 3 times, and each one of those 3 is going to cost me 5%, and each one of those 5% is going to be multiplied times the base amount. Excuse me, 1.15, because there's 3 times 0.05 is 15, right?
Yes.
So you'll notice that what's common, the common thread here is that the calculation structure that we wrote down a minute ago is still the same. We're still doing the times 0.05. Still have the 1 there as placeholder.
And then 1.15.
The only thing that really changed on us is that we just chose a different number right here, just
Right.
because of that first initial step. But everything else is exactly the same process.
Right. And that makes sense. So 1 was going to be 8,000. So any number after 1 will give us a new value.
Correct. I'm
Okay.
telling you, and I'll be honest. This has taken me absolutely years to figure out a way to make it simple and memorable.
Yeah.
I've heard all kinds of schemes and different, because this table's got some weird mathematical properties to it, and you'll start seeing some patterns if you really mess with it too much. But for the non-mathematicians who like to use formulas with stuff, this works because this is a formula.
Yeah.
It's several formulas put together, so it's kind of a process. But as long as you write down this blue framework, which is basically, what you originally wrote down, which is basically, in this case, that right there, right? As long as you have that written down, you can kind of write in all the other values and process it. And if you practice that a couple of times, you'll be fine. All right, now. You have a couple of handouts that those 3 handouts that were stapled together.
Yes.
3 colored ones, the ones got all those tables and charts on them.
Is it okay? Wait, this one here.
That's it right there.
This one.
Yeah. Okay, the very top page there on the right hand side, you see that blue chart and the orange chart below it. The really big table.
Is it this one?
Yeah, those 2, the blue one on top and the one right. Yeah, those 2 right there. Just set that to the side for a second. We're going to come right back to that here in just a second.
Okay.
All right, let's say that we had, and you're going to calculate this one on your own, okay?
Okay.
They gave you in a test question 15 honking ranges. You're thinking, my God, where would I ever see 15 ranges in a single residential dwelling service? Well, that's a good question.
Well, is this for multi-dwelling also?
Yeah, this would be multi-dwelling, but multi-dwellings all have separate meters. I don't have all 15 of them in the same.
But they all have the same. Well, yeah.
No, we're calculating each one of them for that one service.
Yeah, different meters, I guess, but the same service feeding the meter bank, huh?
Correct. So, like, if you had maybe a nursing home or something like that, where you got cooking units and you just got 1 meter, 1 service or something. But anyway, let's say you had 15 ranges and they were equal to 14 kW.
All right.
Average nameplate.
So
you want to try it? You want to try it? On your own?
yes, yes. So the 14 kW isn't really gonna tell me anything because we're not going to use that nameplate.
That's correct. But effectively, that's basically a connected load, and we need to figure out what the actual demand load is.
So we have 15 of them at 14 kW. So
let me ask you this: did we go off the chart?
15. So if we're off the chart right now by 2.
All right, now before you go any further, you've got to isolate that amount that row represents. Row 15.
Yeah, 15 is going to be 30.
30 kW, right?
Right.
So you wrote down 30 kW.
30,000.
Right here.
30,000. There you go.
Now, what do I put right here? The nameplate, right? I'm going back to the actual nameplate because remember that's really what we're, because that this calculation in column C only takes care of the first 12 kW of that number. So I've got to basically take this 14 kW and do this math here, which is the two. You did it in your head just a second ago, but
So we are using the nameplate.
only at this step, yeah. Only to see how far we went off the chart. But yes, we are.
Okay. So 14.
Because remember, once we got this 30,000 over here, that 15 we forgot all about. We don't care about that anymore. So all we had left in was just the 14 kW nameplate.
Times 0.05. Is that going to be well, hold on, equals, it's going to be 10. So 1.10, 0.10, so 30 kW times 1.10, 33,000.
That number that you just calculated is what?
Is the demand load.
Absolutely, you got it. So that, now I want you to take that blue chart and look on row. Do I have 15? I think I have 15 of them. So look on the rows there. You should see number of ranges.
Yeah, 15.
And then go across the top. You'll see the sizes get bigger. Look under the one that says 14 kW.
Oh shit! You got it right there.
So that
little cheat sheet.
Exactly. Really, I really kind of expect you practice this a couple of times and use that just to kind of make sure that your numbers are lining up.
Oh, okay. I see. I could use this against a problem that I create or something.
Yeah, you could literally just grab any random number and test yourself and say, okay, because this is really an important kind of critical piece of this whole thing. It's fixing to get really ugly. And if this causes you a headache, then the other stuff's just going to make you want to quit being an electrician.
Yeah.
I'm telling you, man, sometimes you just wonder, it's like, why am I doing this? All right.
I know. Yeah, because, coming back into motors and power factors and service factors and this, you know what I mean? All these, I mean, I feel like I understand motors real well, but when I start trying to calculate them, it's a whole nother thing, It's kind of crazy.
I mean, if it was easy and there was no math involved, then we'd just be plumbers, right?
Right.
I probably shouldn't say that. One of these days, I'm gonna have a plumber in my class that's gonna my butt.
I heard they were trying to deregulate plumbing, and
they did. They lost their licensing for about 2 weeks, I think. They lost. They had no licensing. Their time went. They expired, and the governor had to rescue them. Had to go in there and do an emergency session.
Wow.
And if he wouldn't have done that, there would literally be no plumbing licenses right now.
Oh, wow.
Yeah. I obviously, working in plan review, I deal with plumbing and mechanical. You know what? I just realized that some of my employees probably watch these videos, and that's. Hey, I love plumbers. Plumbers are great. Without them, we wouldn't have running water. Okay. But it would all be cold water without electricians. That's all I have to say about that.
Yeah.
Let's talk about the two bottom weird blocks down the very where you have really a lot of ranges. I've seen a couple of variations, and I think what I've seen, if I remember correctly, is like 35 ranges that are 15 kW, or it was 35 ranges that were 12 kW. I'm not sure which it was. But I'm just going to work this out both ways so you can kind of see how it works. Okay. So you go past 26 ranges, you get into a demand factor block that you have to calculate your own demand load first before you do the rest of the math. So in other words, instead of it being pre-calculated for you like it is now, you have to do your own math, just like you do with column A and column B. It's not really that hard. It's basically like, look, you have a base block that just the fact that you're in that row, you get hit with that base block. Which in this case, if I have 35 ranges, right? Let's say I had 35 that were equal to 12 kW. I'm just going to put that up there just so we'll have that as a premise. Now, That 15 kW that you see there on that row over on the far right-hand side of the column C, that's a base amount that you get hit with just because you're there. That's it. You have to take that every time. If it was 26, 27, 35, all the way up to 40, I would have to take that 15 kW as a base block. And then, as an adjustment to this number right here, I go back and look at how many ranges do I have in the group.
35.
And then each one of those is going to be multiplied times 1 kW. So 35 times 1 kW is 35 kW. And those two numbers then get added together, and that's my calculated demand factor for that row, 50 kW. So you know how it says 40 right there now on the 25 ranges?
25
35 would give me 50 kW.
25 ranges.
Look in column C. 25 ranges has 40 kW, right?
I see. Oh, in the code book. Okay.
Oh yeah, I'm sorry.
Yes.
So all I'm saying is that this makes sense that this is 50 kW for 35 ranges, right? Because that would be 10 more, and it'd be 10 more ranges and 10 more kW. So
Right.
that sounds about right. And so all we had to do, since that number wasn't already there for us, we had to do it ourselves. That's it.
Right.
Now, the only thing that really changes on that, all the way up to 40 ranges, is just this one step right here where you're doing the extra kW.
Mm-hmm.
If that had been, 36 ranges, then that would have been 36 kW and so on and so forth.
Okay.
If you think about it like this, what that means is basically every extra range just adds 1 more kW to the demand load. So it starts with 15 and just goes up from there. Okay. What if you had, okay, ready for this?
Yes.
What if you had 35 ranges that were equal to 15 kW? Damn it. Knew he was going to do that. All right. Wait. We have a formula somewhere. We have this thing that looks like this. It goes this kW. And then we have minus 12 kW below that. And we have equals some number. I don't know what the number is. And then we've got the, whatever that is, that minus that is equal to this number. And then that's times 5%, right? And then we have the 1 point blank, and then we do the math, right? You remember that formula?
Yes.
What do you reckon I'm missing there? What are the two things I got to get started? Well, the answer to that is going to be, number one, I need to know the nameplate, right? Which is given to me right there.
Right.
It goes right there, just like as if it was 1 range or 35 range.
Right.
Now,
Okay.
What do I put right here for the demand factor in column C?
Well, it's going to be your 2 over 12. Well, your 3 over 12.
I'm not talking about that step.
Watts.
I'm not talking about that step just yet. I'm talking about the block in column C, because column C doesn't have a demand load yet in that row, because you actually have to calculate it yourself. So this number that we put right here, which is what we're going to base the final step against, we need to know what that number is.
Is it 9,200? 9,200?
9,200.
Yeah.
No, so think about it like this. What did we just calculate just a second ago? 35 ranges that were equal to 12 kW, right?
Yes.
And what did we get? We got 50,000 watts, right?
Yes.
When we did the 15 kW plus the 1 kW, which was 35, and we got 50 kW. That math that we did right there was to give us the demand load in column C, which is the row that we're missing right there. That's what we're looking for. Every time we do this formula, we're trying to plug that demand load that's in column C.
You're at 30%. Okay.
Does that make sense? I don't want to lose you. This is really important.
No, it makes sense, but I keep forgetting where we are, and I keep going back to like 1 range with the 8 kW,
yeah.
but we're all the way down here at 35. So 15 kW plus 1 kW for each range.
Right. So forget this number right here for now, because I don't want to get you confused. It's going to be really easy to get confused. Let's forget this nameplate rating for a second and go back to what the values down in that column C say, which is 15 kW. That's not the same 15 kW we got right there. I just happen to use that for the range sizes, so I don't want to confuse you. But 15 kW is what's written in that column C. And then I'm simply going to do that 15 kW plus 1 kW for each range listed in the question, which is 35. So 1 kW times 35, which is going to be 35 kW. So I'm going to then just basically add those two together, which was 15 and 35 was
15 and 35, 50.
That is the demand load in column C. We had to work for it to get it ourselves, right? But there it is.
15 and 35. Yeah.
And I needed this number, right? If I don't have this number, I can't do the rest of the problem.
Right.
Because the rest of it all depends on what I'm multiplying that
1.15 times the
penalty factor.
Right.
So the only difference is they just make you calculate your own demand load. I mean, you just got one extra step. And that is what
yeah, that, how many ranges do we have? 35?
35 total.
Okay. So that is 15 kW plus 1 kW. And if we're up around 41 or more, then it's going to be 3/4 of a kW.
Exactly. I'm glad you said that, because that's exactly where I was going to go. Was guess what?
Okay.
What if we had 45 ranges? Let's just do 12 kW. Just keep it simple. Equal to 12 kW. All right. How do we calculate the demand load in column C for that? Well, it's pretty much the same way, except now instead of a base, demand of 15 kW, now we've got 25.
25 kW.
Because that's what it says there. So we're just going to take 25 kW as the base. Now, what I want you to do with your pen right now, before you go any further, I want you to scratch out that 3/4 that's down there in that on your table. Scratch out that 3/4, and I want you to write 750 watts. Because that's what 3/4 is. We just did the math, so you don't have to try to lose any brain cells in the middle of a. It's sometimes the little things like that, because you're so concentrated on the math of the problem, you kind of forget the little steps. But anyway, so 750 watts. Each range listed in the question is going to get hit with that additional load, right?
So is that another 33,750?
Is that what 750 times 45 is?
Yes.
There you go, and that gets added into that 25. What'd you say it was? 33 what?
33,750.
Or 33.75, and then add those two together, gives us 58.75 kVA as demand load.
Mm-hmm. So, yeah, it is like going in a circle, but I mean, I'm following the beginning steps. It's just getting a little confusing on the way that
you think that's tomorrow or Saturday?
It's tomorrow. I probably should have
done it the day before.
I probably should have studied ovens a little more, but I'm getting it. I think I just need to work it out.
So I have this. I'm recording this. So what I'll do is I'll put this in a link somewhere so you can see it again tonight. You can just watch it in the morning.
Okay.
If that would be helpful.
Yeah. That'll be helpful. I'll watch it again and keep doing a couple more of these practice questions.
Do I need to pay you? Because that's a pretty painful thing to do. I'm sorry. Watching it once is going to be bad enough.
Right.
All right. So I think that's enough of ranges, except the biggest thing of the whole problem, and this is where it gets really ugly. Note 4 is the worst note of the whole table, because everything we've done so far has been based off of a demand load to calculate what the contribution of range appliances add to the feeders on the outside of the building. Calculating a branch is a different animal, because the branch is just that one load, nothing else but that one load. And we really have to make sure that we get it pretty close to what we think is going to happen, because if we don't, we're going to undersize it, right?
Yeah, right.
With feeders, you got a little bit of sloppy room, because you may undersize the the demand load on the range, but maybe you oversize the dryer so it all washes out in the end. But on a branch circuit calculation, you're calculating that one appliance on one set of wire. Now, this table was mainly based as a service calculation, but note 4 says, wait a minute, we're going to let you also use this table as a branch circuit calculation, which means I can calculate out the Romex or the NM cable and the breaker size that goes from the garage to the kitchen. Runs them behind the range in there, the 50 amp or the 40 amp or the whatever we have, right?
Right.
Okay. How do I do that? Well, it says I have to use row 1 only, and that's the big rule. It can only be row 1. You can never use any other row except for row 1 to do any branch calculation. It says it kind of funky, but it says it shall be permissible to calculate the branch circuit load for one range. Underline that one range because that's important. All right. If I have one range, I'm on row 1, right?
Right.
Okay. So what they're saying is all right, I got this. I can make this work. You're saying that simply put, if I have a range that's equal to 9,000 watts, right?
Right.
9,000 watts. All right. Well, 9,000 watts. That is, that's column C range, right?
Yep. 8
right.
kW.
And do we do any math?
Nope.
Oh, it's just substitute, right? 8,000 watts.
Right.
That was easy. Now, they're saying that that number right there, in this case, since there's just one of them, would be the branch circuit calculation as well as the service calculation. Same number. So I would literally take this 8,000 watts as a branch and divide it by the 240 volts that you mentioned earlier. Comes out to be like 33.33 or something.
Yep.
So I would round that up to the next standard size breaker normally, and I would normally put that on a 35 amp breaker. However, we do have one branch circuit rule that you need to be aware of, and then I'm going to take you back to 310.19 B, I think it is, on page 62. I think it's B. I think it's B311. Maybe it's A3. It's A3. So it's 210.19 A3 on page 62. It's kind of on the left-hand column, kind of toward the middle where it says 3 household ranges and cooking appliances.
What page was it again? 62?
Page 62.
Okay.
So left-hand column, kind of toward the upper middle of the page.
Uh-huh.
Household ranges and cooking appliances.
Okay, I see it.
The last sentence there says that for ranges of 8 3/4 kW or more of a rating, the minimum branch circuit rating shall not be less than 40 amps. So because of that artificial rule, I'm not going to have, and we're talking about nameplate ratings, right? So when we go back and look at this problem that we're doing, the nameplate rating, it was 9,000 watts, which is larger than 8750. So we would end up with a minimum, even though this would have normally rounded up to a 35, it's going to be a minimum of 40 because of that.
Yeah.
Okay.
So the 8 3/4 kW minimum is 40.
I just wanted to cover that with you, just so you, in case you. We also have another rule since we're talking about this, and so on the bottom of page 74, what I want you to do before we go any further, I want you to write branch circuit, however you want to write it out. You can spell it out if you want to. Minimum circuit rating or circuit size equals 40 amps. That way you don't forget that rule that you just looked up.
Did it tell us where that rule was on this page here, on page 74?
No, they don't say work about.
Refer back to that rule.
It's a different code making panel, and those two code making panels don't like each other, so they don't want to talk about it.
Mm-hmm.
I don't, for real, I don't know why they don't reference it. They should, because they directly relate to each other, but there's nothing on there that says it as far as I've ever seen. So
right.
Now there's also a maximum amount. You should never see a range larger than 50 amps. So branch circuit max is equal to 50 amps, no matter what. Single family, residential dwelling, or 2-family or multifamily, basically residential dwellings, will not ever have anything larger than a 50 amp circuit for the range. You want to know where I got that at?
Sure.
I'm glad you asked. For 422.11b, I believe it is.
22.
How do you remember all this stuff?
How do you remember all this stuff?
Pure repetition. 422.11b. I've been studying for my test every day for years.
Yeah.
So on page 276 on the right-hand column, kind of toward the middle, it says 422.11 overcurrent protection, and then B, household type appliances with surface heating elements, i.e. basically a range is what that is. They can have the maximum demand of up to 60 amps on the branch circuit, but you cannot protect it with anything larger than a 50. It's one of the rare places on that smaller size stuff that you could actually see demand loads that are actually bigger than the breaker size.
So if they have a demand factor of 60 amperes, would we size the wire to the
60 amps?
To the 50 amp breaker?
No, to the 60. The wire always gets sized to the demand that's going to be expected of it. So if your calculation is 60 amps, you'd have to run a number 6.
Number 6 to a 50 amp breaker?
Well, I mean, yes, that's exactly right.
Huh.
It's weird, but that's exactly correct.
It is weird.
I actually had that. If you go past that, then you actually get into subdividing the loads, and you'll see that. And that's actually a test question that you might run across. Any kind of like resistant heating element. So if you look on page 277, since we're here and talking about it, note F, which is on the, or section F1, which is on the left-hand side of the page there.
Okay.
Actually, is this a 2020? No, it's 2017. I'm sorry, E at the top. No, that's where I want to be. Was F? I'm sorry.
F, electric heating appliances.
Yeah. Under F1, it says electric heating appliances that have ratings or elements that are rated more than 48 amps. You actually have to subdivide them into separate circuits. And that didn't make any sense to me for a long time until I did a project one time where this guy had bought this home. It was a whole house tankless electric water heater. Came from Germany, and it came in the box with 2 60 amp disconnecting, and you had to run 2 separate circuits from the panel into each one of these disconnects, and it combined and went into the unit.
I've seen that on furnaces, heaters.
There you go.
Yes.
Electric heating.
I wondered why they did that.
Right there. That's the reason why.
Oh, wow.
Okay, going back to page 74, the page you love to hate.
It is.
Page 74. All right, now. Branch circuits, right? What if I had more than one range in a test question and they asked me to calculate a branch circuit? Remember, the number one rule for branch circuit calculations is I can only be on row 1, right?
Okay.
That's basically what it said. Now, if I can only be in row 1, then how could I have more than one range and still make this work? Well, the second part of note 4 gives us an allowance for that. The second part of note 4 says, okay, we're going to let you take a cooktop and up to 2 wall mounts, and we're going to let you pretend like they're all going to combine into one gigantic single range. So they basically cheated. They told us what the rule was and says, but then, if you have 3, we'll just cheat it and make it sound like it's just 1.
Mm-hmm.
Now, they did that because they want us to be on row 1. The row 1 is the most important part because the values that we use in row 1 are unique to row 1, so that's why. Now, what does that mean? Well, let me show you. Let's go back and take a step back. You always have to ask yourself this question anytime you do any range question, and that is, are they asking me to calculate a service or are they asking me to calculate a branch? Because You're going to see here in just a second, they're two totally different answers. Let's do a service calculation. Let's say that I had the following three ranges listed in a test question. Say they gave me one that was 4,500 watts. They could call it a cooktop or they couldn't call it. It doesn't matter. I mean, they're telling me they want me to calculate a service, right? Man on service.
Yes.
So give me a 4,500 watt range, and then they give me a 5,000 watt range. And they may say it's a wall mount. That doesn't matter if they do or not, but we'll just say it is. And then they give us another one that's 5,500 watts that's also a wall mount. You remember the I Dream of Jeannie show where she had the double broilers on the wall and then she had the other oven that's underneath the counter? So
Yeah.
that's in the 70s, and it's kind of making a little bit of a comeback. All right, now, here we go. As a service calculation, I go to row 3, remember, because I have 3 separate units. Those are all column B, right?
They're all in column B, yes.
That's right. So that's B, that's B, that's B. All right, so I'm in column B. I'm on row 3, and I have to do my own math. I go, okay, great. That's 55% demand factor. So I'm going to have to add all these up and say, okay, this is going to be 15,000, right? Combined, I have to multiply that times the derating factor of 55%, row 3 in column B.
0.55.
So 15,000 watts times 55.
8250.
Thank you. All right, this is important. All right, so 8250. Now, that would be 8.25 kW. That would be my calculated demand load on the service, right?
Right.
All right, now they're saying, oh, wait a minute. Forget that. We want to calculate the branch. We want to run a tap conductor from the garage. We've got, our distribution panel in the garage, and we got the kitchen way over here. Rather than running 3 separate circuits all the way up in the attic and all the way over to the other side of the house, we're just going to combine them all into one wire, put them on one breaker, and instead of running 3 separate ones like I've got drawn here, we're just going to run one great big wire with a bigger breaker, and then we're going to tap off of it when we get into the kitchen. And it used to be real big practice because they bring it in behind the cooktop, and they'd put a junction box there, and then they would tap off of it to the wall mounts, cooktops, whatever. It works. We could do that now. All right. So this question gives me the same ranges that I just had over there. I've got a range that's calculated as 4,500. And here, when they tell me that it's a cooktop, it actually matters. Because with a branch, that's an important piece of information. So I got 4,500 on cooktop, and they tell me I had a 5,000 watt, that's wall mount, and 5,500 watts. Same exact 3 ranges, right?
Right.
But the difference is now I'm calculating a branch, not a service. So note 4 tells me I'm allowed to combine all of these, and instead of being on row 3 under column B, I'm now on row 1 with one range that's equal to 15 kW.
Okay. What note allows that? Number 4. If you're calculating a branch circuit, it allows you to do that?
Yep. The second part of note 4 tells you that you can combine a cooktop and up to 2 wall-mounted units and treat them as if they were one single appliance.
Okay.
You see what's happened here is we now have do you remember the calculation we started with, and I told you you're going to have a lot of stuff on row 1 that really gets to be big ranges? Well, this is the reason why.
Okay.
You start adding 3 ranges together, you're shifting columns now. Instead of being in column B with all of them that like they were natively under service calculation, now we've shifted columns. We're in row C.
It's taking you to C, right? Mm-hmm. And it's calculating it for you.
And use your little formula and tell me what the demand load for a single 15 kW range would be after you put it in your formula, your little bracket. Because remember, that's a connected load. That's not we have one more step. We need to know what the demand load on the, I'm sorry. Yeah, we still have to do the demand calculation.
What was it? 15,000?
Because remember, row 1's only good for 12 kW, so you got to deal with
You got to add 2. Or 3.
3, yeah.
Right. So 3 kW on top of it. So 15 kW.
So is the answer going to be, I'm just going to give you some options. 15 kW, 18 kW.
Wouldn't it be 11?
12 kW, or let's see here, 9600 kW. I can't write. I'm ran out. I got a picture on my iPad. I can't get it to move. There we go. 9.6. No, 9.2. I'm sorry. I'm doing this in my head. 9.2. 9. So it's sorry. It's not 9.2 kW. So that's your choices. Which one of those answers is your correct answer?
I don't know why I'm coming up with 11.
I want you to reason this out. I didn't even give you 11 as an option. I'll give you that as an option. We'll make that 12. I mean, at least you know that's not the right answer, right?
I know that's not the right answer.
It's important that you make this connection in your mind, because this is really goes back to what we started with.
I mean, it would be 2. I mean, we're going to calculate all these as 1 now. So we're staying on row 1, right?
Go back to that bracket. Go back to your bracket, your formula bracket, and just plug that 15 kW in and tell me what it gives you.
Okay. Okay, 15 minus the 12. I would give minus the 12.
Right. So that's 3 steps, right? You went off the chart 3 steps.
Yep.
Each one of those steps costs you 5%.
Yep.
5% of what? All right, I'm sorry, 15% of what?
15%.
Are you in column C? On row 1 in column C?
I was trying to input it into this bracket that I made earlier.
What is well the box that we're multiplying that 15 is the demand load that's in column C. What is the demand load in column C for row 1?
8.
That's your ball and chain. You'll always have at least 8 or something else. So that 15 kW that you calculated there originally when you added those together, that's the nameplate. So the first 12 kW of that is going to equal 8,000 watts, because that's the demand load in column C for 1 range. So we literally basically took the 15 kW and we subtracted the value in column C, which is the first 12 kW of that number, which is substituted for 8,000 watts. That's what the demand in column C is. And then the difference between these two, the nameplate and that 12 kW, oh, I just erased everything on accident. So it came back. Well, that's neat. If I could figure out how to do that on purpose, that'd be pretty nice.
Yeah.
Let me just erase this. All right, here we go. I figured it out. All right, so what I did was, remember I had my blank up here, kW minus 12 kW equals 8,000 watts if I'm on row 1.
Right.
In this case, 15 kW minus 12 is 3 kW. Each one of these is a 5%, which is 1.15. And then the last step was I had to multiply these two together. 8,000 times 1.15, which is going to be basically 3 times 400 watts, right? Which is 100 watts, which is 8,000 plus 12, which is 9,200 watts, or 9.2 kVA.
Mm-hmm.
Now let me do that.
How come we didn't do the 8,000 times 1.15?
We did. This right here gives us that number. It's
Oh.
also the same number if I did it my way, which I said earlier was just a shortcut.
We're 3 kW off, and then you just times the 400, and then you added the 1,200 on top of the 8,000.
Yep, that's exactly right. That's just a shortcut of doing it. But like I said, you have to know that 5% to be able to do a lot of the other rows. So it's a good habit to get it used to it.
Hmm.
It's just faster to do the 400 watts. But like I said, if that gets you in your way, I don't want to make it any more confusing.
Yeah, that's why I don't know why I was just thinking I could take that 8 kW and add the 3
kW straight to that number.
That's where I got the 11 from. that's, well, I guess it kind of threw me off.
All right. So seriously, so there's basically there's two things that at the end of this whole thing, what I guess I want you to do is I'm going to go back real quick. Now remember, so what you have right now is this 9,200 watt, right?
Yes.
If we go back and we look at the one we had up here before, if I can find it, see if we go back enough, let me pull that up again. 1 second. We're almost there. Come on. There we go. Now, so same exact ranges. The only difference was they were asking me a service calculation versus branch, but look at the answer differences between the two. One is this, one is this.
Right.
Two completely different calculations, two different answers, one being branch, one being service. So
And the branch, the reason we got that was because we were able to add them all together and use one. In the service, we had to go into the columns, and yeah.
The difference is we add them together to shift columns if we're doing a branch circuit calculation, whereas otherwise on a service calculation, every range is its own unit and its own row.
Okay.
So let's try one. Let's say that we had, let's say they just gave us a range that was 9,000 watts. So they get, this is grandma's house. So she got 9,000 watt, what do you call it, cooktop? That's a heck of a cooktop. All right, and then we've got a 4,500 watt range that we call a wall mount, and 5,500 watt range we call a wall mount. If I'm calculating out a service calculation, what would be my demand load on the service for those three ranges? On the service.
We could combine the bottom two. Well, because you have the 9,000, we could combine them all into column C, right?
That's correct, because column C doesn't play well there. So they're all column C ranges anytime I have a situation like that. So, but the difference is I'm not adding them together to be on row one. I'm on row three because I got three separate units, right?
Right.
As a service calculation, each appliance counts its own row. So I'm going to look at, that's simply 14,000 watts. That's strictly the demand in column C. I didn't go past 12 kW, so I don't have to do anything else, right?
Right.
All right. What if they were asking me the same question, but they wanted to know the branch calculation? Now remember, this is my answer as if it was a service calculation. So I'm just going to write that over here just so that we don't forget it, but just ignore it because this is just the answer of the service calculation. All right, so we're doing a branch calculation. Now they're going, okay, we want to know what this thing would be as a branch calculation. So as a branch, then the cooktop and the wall mount matters because that's what the rule in Note 4 is. I'm allowed to combine a cooktop and up to 2 wall mounts into a single unit. So what do you get when you add those three together? If we combine those three into one big unit, let's see, 10,000, 19,000? I think right.
100. Yeah, let me see. 9 plus the 4,500 plus the 5,500, 19,000.
Okay. What we just did was we said, okay, wait a minute. We don't have 3 ranges in column C. We have 1 range, and it's a gigantic range. It's 19,000 watts. So now I'm going to row 1.
Yeah, so now
plug that 19 in and tell me what it is.
well, now we're over the 12.
Right. So we go back to that formula. Plug straight into that formula.
Can I take the difference between those two and then times it by 400?
You certainly can.
And then is it going to come out?
Yep, it sure will.
The 21,800?
So we went past that, what, 7 times?
Yes.
Each one of those is 400 watts?
Yes.
That's 2,800 watts?
I think yes.
And then we just multiply, add that to 8,000 watts, and it gives us 10,800, right?
Yep.
Check that blue chart there, see if that jives with the little blue table there. I'm pretty sure it is for a single 19 kW range on that top row. What do you have there? 10.8.
The 19 kW.
Single range.
10.8. Yep, 10.8. There it is.
But again, I'll go back and point out that, look, as a branch calculation, our calculation was 10,800. As a service calculation, it was 14,000 watts. Two totally different answers.
Okay, right.
It's imperative when you read a question, you ask yourself, are they calculating a service or are they calculating a branch? Because the approach is different. I told you, I promised you it was going to get hairy. I told you it was. At least I deliver on what I promised, right?
Right, right.
What else you got? I'm done with ranges. I'm sick of them.
Oh, man, I'm telling you. I don't know.
Something easy.
The
Like let's calculate out some big motor circuits or something.
yeah, I mean the motors. Let me see
Have you taken your test already?
I did 3 years ago,
Okay.
and I think I would have passed it if I would have had a little more time. I got a 68 on it overall, and I ended up having to guess on like the questions that I flagged. I had to go back to that I thought were going to be longer calculations. So I just kind of started giving it my best guess, just punching numbers in the calculator and just trying to just rush through the flagged ones. But I think if I would have had another hour, I would have been just fine. But
well, I mean, yeah, that's the reason why they limit them, just because they know that kind of qualifies they expect you to have these answers kind of fairly close to the readiness, because that's what, if you've been practicing, it should be kind of the theory. So that timing part is just meant to kind of mess you up. I'm telling you, that's why they give you hard questions in the very beginning on purpose. They're just trying to just kind of unravel your cage and just kind of slow you down, I think. But
right.
Not everything's a conspiracy theory, but when they're really out to get you, they really are out to get you, right?
Yeah. Yeah, I feel like if I'm going to come across another question, I think I'm going to spend too much time on it. First, I'm going to try to understand the question, read it a couple times, and if I feel like it's going to be way too much calculation, I might just come back to it again.
Well, those questions that I gave you on that one, the one that starts with that commercial kitchen. Those are the ones that are fairly recent, and I saw them enough times from enough guys that I feel pretty confident that they're pretty accurate. If they're not at least accurate as far as like the actual numbers, they're really close approximations of it. But you should have gotten an answer key from her that kind of worked her way through all those. Did you have a chance to do those?
I did get the answer key. I haven't had time to go over it. No, I haven't even printed it out. I've been just kind of working it off on my phone.
Do that tonight, because those are you literally may have 5 or 6 of those same exact questions tomorrow.
Yeah. Okay.
On your test, so it'd be good practice for you to kind of give you a feel for where you're at.
Right.
And you might even actually remember some of them. If you get down to the end of the wire, let's see, what time is it right now? 9 o'clock. So it's probably you're going to go to bed here pretty soon, I'm sure.
Yeah. Yeah, that's about an hour north of me too. I got to drive.
What time do you got to leave in the morning?
I think I'm going to leave here like at 6:30, and I'm going to get there a little early, and then just kind of I'll probably start going over these exam questions in the parking lot before I go in.
I usually go to like a Denny's, have a cup of coffee, and then just kind of get my head together. So, but please try. I wouldn't do anything else tonight except those questions.
Yeah. Yeah, I feel like I'm probably going to end up overloading myself.
Well, like I said, the only reason why I say that those would be worth it is because if you actually have some of those and then you kind of remember the answers, that might be good. But I tried to work them out fairly well, so I think you've got some good examples in the answer key. But it's up to you. I mean, depends on how you feel on, I guess, on the motors and stuff, really.
Yeah. Well, I understand them a little bit. It's just some of the questions get a little tricky. Fire pump motors. Do we always have to size those feeders for like lock rotor?
Nope.
No.
feeders for a fire pump with feeders, right? Not the overcurrent protector, but feeders for a motor are no different than any other motor that's 125% of the FLC.
So when does the lock rotor rating come in for fire pumps?
You want that overcurrent protection device to darn near just not even work. Because the last thing you want is that fire pump motor to go out because it got too hot.
So size in the fuses that feed it, or
Right.
the overcurrent
protection.
device?
Yep. It has to be sized to carry the locked rotor current for an indefinite time period, which is pretty damn high.
I did have one more question, and it was on your answer sheet here, but I can't find it. I didn't know where you got, I think it was 95%. I don't know if that rings a bell to you, but.
Was it a voltage drop at fire pump terminal?
No, it was on the prep exam, and you used a 95% calculation, and I didn't see where you got that from.
You know what
It was in your notes. You put notes right next to all the answers, kind of shows how you got the answer. And
that was the very first test we took.
yes.
The only 9500 that I can remember off the top of my head is the bank office receptacles. Is it that one?
No.
Cause I want to say the banks were like 9,500 square feet or something, and that would have been.
Okay. If I see it, maybe I'll shoot you an email.
There's not very many. I don't know too many. In fact, I don't think I know any 95% demand factors or anything like that. So I don't think it would have been. The only thing I was thinking of is that there is a voltage calculation or a voltage drop value for fire pump motors. So at the terminals, you shouldn't experience more than 3% for run load or 5% if it's a startup. Let me see. It's 695. I don't know this one off the top of my head, so I always have to look for this one. But I think it's 5% for that voltage drop, which means I'm taking 95% of the system voltage to calculate that out. And that is on 695.7, which is page 579. And it's 15% or 5%. So starting is not more than 15% below. So I'd use 85% for that, but the running value can't be less than 5% below the voltage rating of the motor, where it's operating at 115% of the full load current rating of the motor, which is pretty typical to the overload sizes. We use 115% a lot of times for that. So.
Okay. Maybe that's where I was reading it. Or.
So yeah, because that's one of those problems that I have and I would have used 95% for that because that is the number that we would use for. Because if you've got a 5% voltage drop, that means you're keeping 95% of the voltage. So it's faster to just do it that way.
Okay.
95% of the voltage, then it would be to do the 5%, subtract it, yada yada yada. So.
Right. Okay. Okay. Well,
I'm not rushing you.
No. I was just reading some of this other stuff here.
I'm sitting here just fiddling, so I got time.
I weigh less than 1 pound.
Baby mama says go to bed.
I'm not mom.
Oh, baby mama.
He said baby mama.
Oh, baby. Yeah, baby mama said
go.
I don't know. Please tell her that I would have never said that she looked like your mom. That's not.
He's having a good time.
You guys ready for Thanksgiving?
No.
Thanksgiving is nothing but football and beer and turkey, so I think it can't be bad.
No, if I can get past this, then I can start thinking about that.
Be like Christmas.
Yeah, we're gonna be pretty busy, but hopefully everything goes pretty smoothly. But
I would give you, my suggestion on it, kind of taking the test changed a little bit when they went to this split test, because I mean it's hard to do anything but answer the code questions as they come, because at 2 minutes a question, you're really kind of challenged to get through it in time.
Yeah.
So on the code lookup stuff, you just need to answer them as quickly as you can. And if you can't find it immediately, mark it and just keep rolling. And then at the end, if you've got any time left over, then you go back and look at it. But I mean, I've not heard too many people that had a lot of time left over, because 2 minutes a question is booking it.
Yeah. Is it still, what is it? 100 questions?
140 questions for
140?
Yep.
Wow.
For 75 questions.
Yeah, I heard that the test is split now, so we don't have to retake the entire test if you don't pass a portion of it.
Yeah, and that's true, and that will stay with you even if your license expires or your application expires. You have to renew it. You won't have to take that portion again. It'll stay with you, forever.
Do you know how much time they give you on each portion?
So they give you 140 minutes for the math part. I mean the code part, and then the math part they give you the balance, which is like 3 hours and something. I think it's plenty. You have plenty on the math part. You've got plenty of time. Don't be in a huge hurry. I mean, don't dilly dally or anything, but you got time.
Right.
The code book stuff though, you do not have time. Do not stop. I mean, just keep rolling. If you can't find it within a minute,
Yeah.
Move on, for real.
Well, I'm going to try your method too, because I'm an index guy. I jump to the back of the index, and I know you said you use the front of it.
I hate that index. God, I hate that index. I swear to God. I'm telling you, every time I ever take a test, I always go in there with an attitude about it, and I'm like, I'm not going to use it, and I don't ever use it, and then I'll have like 3 or 4 questions at the end that I can't find any other way, and I go, okay, fine, I'll try the index. Sure enough, never find them.
Yeah. So maybe I'll try the front of the book. I've never tried the front. So, and I know we had that trouble the other day in class. We couldn't find, what was it? Plug.
Oh yeah, plug-in boxes.
Plug-in boxes or something.
Yeah, definition of plug-in boxes. It's one of those things that I like it just because, number one, it's got page numbers, and I tend to kind of use my thumb to get my way around the bottom of the book when it's laying in front of me. So I'm in the front of the book with that table of contents, and I find a page number. All I have to do is just literally run my thumb until a page pops up. But more than anything else, I just like the fact that I can look at everything in chapter 5 all together at one time. So I can pull out sections a lot faster and get around the code book a little bit better, I think. But you do have to, you're going to have to probably kind of look at that a little bit in the morning before you go in there, because if you haven't used it before, it might, I don't want it to slow you down and be the reason why you don't pass. So, if you, at this point, it might be better to just kind of keep it for just chapter 3 stuff. If you see a chapter 3 question, for sure use it, because it's so much easier than the index. But
yeah, that's how I did the journeyman test, just flipping through the book like crazy, like a madman. And I've taken it twice, once in California and once in Texas. And the first time I passed both of them the first time. And then I thought maybe I was going to be able to weasel my way through the masters like that too. So,
I'll tell you right now, I would be surprised if on an average master's test, there's more than, say, 20% of questions that are even in the index. The rest of them, you just either have to know how to find them or find a way to get around. It's
right. Yes. And you're going to have to know the exceptions, and it's just a lot more calculations. So it caught me off guard a little bit, but
Somebody told me I've had a couple people in class tell me that they actually had a couple of calculations. They're simple calculations, but they're calculations nonetheless, even on the code book section.
Yeah.
So I'd be interested to know if that's true. So call me tomorrow when you get done and let me know.
Yeah. I'll let you know how it goes, and then if I need to, maybe I'll meet you guys in Austin.
Yeah, if you don't pass, then let's do that. That's really going to be the answer to it. This is a difficult test, right? And so you just got to go into it respecting it. Don't be scared of it, but respect it for what it is. And if you don't pass it, it's you're not the only one. It's 20% pass rate right now for a reason.
Yeah.
So
right. All right.
I'm going to try to get this video rendered and back out like right now. So no promises, but I hope I will. And if I do, Let me get your email address. So
Okay.
I know she has it, but I don't. So let me, whenever you get a chance, shoot it to me.
Yeah, I could, you ready for it? You want me to tell it to you?
Yeah.
It's David. And then it's the letter J. Payne, Payne.
Okay.
80 at Yahoo.
Okay. Can I give you mine?
I was emailing, let me
No,
see.
can I give it to you? You got a pen?
Yes, I do.
Oh, here, you know what? Look, here, look. It's,
Go ahead.
be easier if you could just, it's STRAIL at yahoo.com. You can just shoot me an email real quick. That way I'll have your address right on the top of my box and I can shoot
Okay.
it to you.
Let's see here. STRAIL.
Had that email address a long time back. I mean, Yahoo, a five letter or 5-digit Yahoo email address.
Oh yeah, that is an old one. Okay. I think it says it sent it.
All right. I will check it here a little bit and
Okay.
respond. But I appreciate it, sir.
Yeah. Hey, thanks for spending a little bit of time with me and helping me understand this this oven page a little better.
All right. I'll do my best to get this out to you. If I don't, best of luck to you tomorrow. And if you get stuck or something, just text me. You have my phone number, right? It's on that little card.
Yeah, I have the card here.
And then if you don't mind, call me when you get out. I mean, call your wife first, obviously, because she counts. She's definitely prettier than me for sure. But if you could just give me a call and let me know how it happened and how you did, I'd really appreciate it.
Okay, absolutely. I'll give you a call tomorrow.
All right. Good luck.
All right. Thanks a lot.